There are 2 poles. If it is positive, system is unstable. If it is negative, system is stable. If one thing is positive and if it is 0, it is unrepeated. We can say that it is what? It is what? Marginally stable. So I'm gonna write it down. S is positive, we say unstable. Which system is marginally stable. But S square is equal to 0 to before taking repeated multiple poles at origin. Which means multiple poles at imaginary axis make it unstable. Unstable, stable, marginally stable, and then again unstable. Steady state error. Codynamic consists steady state final difference between desired target input and actual system output as the time goes infinity. Transient response to temporary behavior of the system and output to immediately action in the steady state level. Transient speed of our system created to change measured by rise. TR, time taken rise, something like that. Damping and acceleration. Damping the internal resistance of frictions that opposes motion and surfaces oscillation. Oscillation. Steady state. Overdamp. එකට වඩා වැඩි නම් මේක අපි කියනවා overdamp, no oscillations කියලා. ඒකට සමාන critically damped. Connecting. I don't understand this. That's problem. Connect to new nodes. Make how that will this time I think I need. Oh, I'm done. This mouse doesn't work and it makes me so stressed because I am in a rush. I'm in a rush, a little bit of rush. So this doesn't work. Yeah, okay. Not functioning. Maybe we need to connect this house somehow. Let's just connect this mouse first of all. And then after that we can work with this. So I had today the whole day but I never worked. So that's like a tradition of me that I wait till the last minute to prepare for the exam or any kind of thing. So this is me being me. So I would have to stay up all night. Maybe not. Probably I will have to. So I'm going to be doing that. I had the time. I wasted I think about 3.5 hours today. The time that I should be studying and alright, mouse works. Yeah, now getting to the why the hell? Let's just close this and then close this and this and this and then this. Why? Something is wrong. What is wrong? Let's just try to find out. I think some keys are no keys are not missing. If somebody has pushed control key and then if I go like this, what the hell? What the hell, man? It just opened a new window. I don't know. I really don't know. Let's just go with the flow. I have nothing to do other than that because since this is not working, I'm gonna be satisfied with the way it is working. Because I can't fix it right now. What? I think the control button has pressed somewhere without any. Alright. And then I just spared it to ChatGPT and ask the questions. අනේ ChatGPT මට මොකුත් තේරෙන්නේ නැහැ මේ කියන දේවල්. පොඩක් කියා දෙන්නකෝ මේවා. මට එනවා තේරෙන්නේ නැහැ. අනේ හොරි වෙන්නේ කවුරු ස්ලයිඩ් එක වලින් ෆෝර්මුලා ගොඩක් තමයි මේකේ මොන සෙන්සස් පාරකට ट्रांसफर फंक्शन එක බලමු. ඒකේ තියෙන ස්ලයිඩ් එක මේක තමයි සෙකන්ඩ් ඕඩර් සිස්ටම් එකක් කියන්නේ. එතකොට මේ ෆෝර්මුලා ඔමෙගා n කොහොමද තියෙන්නේ? එතකොට ඔමෙගා n කියන්නේ natural frequency. සරලව කිව්ව සිස්ටම් එකේ ඩැම්පින් එකක් නැත්නම් මේක කොච්චර වෙගෙන් ඔපරේට් වෙනවද ඒක තමයි natural frequency කියන්නේ. ඩැම්පින් රේෂියෝ තමයි මේක. මේක එකට වඩා වෙනස් දීන ඕවර් ඩැම්ප් ස්ලෝ no oscillation ඒක critically damped ඒ කියන්නේ fast no overshoot under damped under oscillation overshoot under damped continuous oscillation so maximum percentage shoot means I don't know what is going on. I don't understand. Let's just again ask questions. Hey ChatGPT, the explanation you gave me is still unclear to me, and it is terrifying to see this much of complex theories the day before the exam. I'm just learning it today, so it is hard. Can you please explain it in a simple manner, thinking of somebody who doesn't know anything about these control systems? I only know the transfer function, but I never know that crazy sign or crazy I don't know the letter they use to name the ambient ratio and I don't know natural frequency and stuff like that. So like should I learn some things before this, and are there any particular some kind of things similar to it that I should learn in this subject? Like I feel like I'm missing things, and that's why I'm terrified to uh, watch and because this is just the day before the exam, but I'm just seeing it now. So it is like I'm afraid that I will fail. So can you explain it in a little bit simple manner so that I can understand at least? And it should come to this complexity step by step. Uh, yeah, please save my life today because I'm just in a very yeah, not a good state. Let's see what the GPT says. So I got few more questions to answer, and in there I need to learn some things. I spent all day today uh, watching crime documentaries and about psychopaths. Man, I have exam tomorrow. What a stupid person I am. So hey, first take a break. You're not stupid. Oh, thank you. And you're not behind because this looks terrifying. This slide is ready for someone who already knows what can do. If you only know transfer functions, then of course I'm saying is um in those words, Routh feels like completely different language. Good news, you don't need to learn all of control system tonight. I need to learn all of control system tonight, man. Tomorrow is the exam. We can build the small foundation you need and the time to this slide. Think of it like this: transfer function, denominator, pole, stability, second order systems. Blah, blah, blah. That's the road. Okay. What do you know? Already know. I know the transfer function. Alright. For example, GS. GS is that's good enough stuff. The transfer function usually looks like numerator and denominator. So um, for today's topic, denominator is extremely important. So why? Because the denominator tells us about the system's poles, and poles tell us whether the system is stable or unstable. So when we try to figure out the poles and type of the control system, we look at the denominator poles and the type of the control system. When we try to look at the all of the system, we just look at the trans function. This is GS. I don't know. So in here, this is also trans function, right? So I don't know. Yeah, so because the denominator tells us how the system holds, the poles tell us whether the system is stable or unstable. Transfer function, look at denominator, find stability. Well, that's big picture. So what on earth is S? You're probably seeing S on transfer function already, so now don't make it complicated. Just think S is variable. Using Laplace domain to represent the system. You don't need to deeply understand Laplace transform tonight, just to understand the slide. So if you see s square plus 3s plus 2, just treat this like an algebra variable for now, like s square plus 3x plus 2. Control systems uses, so what are poles? This is one of the things you probably missing. Suppose gs is equals to 10 over s square 3s plus 2. The denominator is s square plus 3s plus 2. To find the poles, we set the denominator equals to 0, and we get the denominator. So those are the poles. So remember the poles, values of s that make the denominator 0 enough for now. So why do we care about poles? Because of the stability. Very roughly, poles on the left side stable, poles on the right side unstable. We don't need to worry about the whole complex plane right now. For basic exam idea, all poles have negative real parts but stable. pole has positive related part unstable. So and that's why Routh Hurwitz exists. So what is Routh Hurwitz? Now that scatter slide suddenly becomes much easier. So you imagine I give you this s cube to s square plus 3s plus 4. You could technically solve this equation and find poles, but sometimes the polynomial is difficult. So instead of solving for every pole, Routh Hurwitz gives us a shortcut to determine whether the system is stable. That's it. So Routh Hurwitz a shortcut for checking stability. You don't need to think of it as some state-defined theory. What does Routh table do? Suppose we have s cube 2s square plus 3s plus 4 is equal to 0. We take coefficients 1, 2, 3, 4 and we arrange them in Routh table. So when s cube 1, 3 and 0. S cube square 2, 4 and 0 and S1 is but S1 is 3, right? I think where is wrong? Oh no. And then what we're gonna do is 2 times 3 is 6 and we minus it by 4 and we divide it by 2 we get 1 and then we don't have any number there and we just write 0 here and then we do the same thing right here which means we multiply 1 by 4 and we reduce 0 from it and we get 4. So this is don't worry about the don't worry about where one and the third row came from. Two sign changes means unstable force. If signs are not changing, it is stable. Now let's come back to the this sign. I don't know how to pronounce it. So let's just ask it from someone who. Again, ChatGPT or another Gemini. Let's just ask from Gemini. How to pronounce this? How to pronounce this? The Greek letter uppercase Z, lowercase means theta. English pronunciation is zeta. Zeta. In American, theta. English, zeta. Zeta. What is Greek pronounced in English? Like Z as zoo, zebra, and letter name is pronounced zeta. Zeta. Ancient Greek sound pronounced either as Z like SD in Wiltons or DS like DS in Rhodes. I don't know what are this, but I think it is called as zeta. Zeta. So this is zeta, okay? I don't know how to write that down, but somehow it is damping ratio. So this completely different piece of vocabulary. You start says TS is equal to this. Don't try to memorize the whole thing immediately. Just try to understand two new symbols. Omega n. The funny symbol omega n. This is pronounced as omega n. It means natural frequency. You can think of it as how naturally quickly the system wants to oscillate. And zeta. This funny symbol is called zeta. It represents damping ratio. Think about a spring. If you push a spring and release it, it might go up, down, up, down. That's oscillation. So damping is like what kills that oscillation. So what kills that oscillation? How much damping the system has? I don't know. Alright, I just understood it a little bit, but let's go further. So the easier way to understand damping, imagine a car suspension. Very little damping, car goes up, down, up, down, up, down, lots of bouncing. And that's roughly zeta is between 0 and 1 underdamped. I don't know what is that. Perfectly damped means the car returns to normal quickly without bouncing. That's zeta is equals to 1. Critically damped. um, suspension is one. And then car returns slowly. That's zeta is equals to zeta is greater than 1. So over damp. So just remember this picture. So little to damping, bouncing, perfectly damping, fastest without bouncing, and too much damp slow. So that's what those 4 lines on your slide are trying to tell you. And so what is the second order system? This is another thing that sounds worse than it is. Look at S square plus 3s plus 2. The highest power of S is 2. Therefore, its second order system. If the highest power is S, first order. If it is S cubed, the third order. So highest power of S is a system order. Alright, I just learned it previously, I think. Yes. Highest power. Oh, yeah. That's the order. Alright, I got it. So, yeah. So the control system type, we measured it by forward system transfer function. GS. If it has S times something, so it is type 1. If it is S square times something, it is type 2. If it is S cube times something, it is type 3. Likewise. So that's it. So I just learned the order. Order means the highest power in the denominator of the transfer function. So this is second order something, I don't know, the second order transfer function or something like that. So this is basically a standard format. If your denominator look like this, we compare with this. So this is s square plus 2 zeta omega n s plus omega n square. So the last number is omega n square is equals to 9. So therefore omega n is equals to 3. Then 2 zeta omega n is equals to 6 over 4 over 6, which means zeta is equals to 2 over 3. That's it. So this system has omega n is equals to 3 and c is equals to 0.67. Since zeta is between 0 and 1, this is underdamped. Oh, that's how you get it. Alright, I got it. And then you come overshoot, like see, once you know zeta, you can calculate things like maximum percentage overshoot, overshoot. Don't look at this and think I have to understand every part of this formula right now. Yeah, that's just what got to my mind. But yeah, no. For the exam, think if they give me zeta, I can put it into the overshoot formula. That's calculation. So if they give me zeta, I can put it into overshoot formula. All right, and then calculate it. So what is overshoot? Maximum percentage overshoot. Maximum percentage overshoot is equals to e to the power minus zeta phi over square root 1 minus zeta square times 100. I don't know, it seems a little complex, but somehow, yeah, that's the equation. So uncertain time, again, once you know zeta and omega n, to present means T is 4 over zeta omega n, and these are not the separate theories, the connected. Transfer function, overshoot time. What do you think actually is missing? From what you told me, I don't think you need to go backward and study an entire control system course. You need a small vocabulary foundation. Please, somebody call me. Before trying difficult questions, make sure you understand this. Level 1 must know transfer function. Numerator versus denominator is polynomial order system, pole, stability. Second order system, omega n, natural frequency, zeta damping ratio, overdamped, critical damped, underdamped. undamped. Calculation omega and zeta percentage overshoot settling time. Stability shortcut, root array, first column, sign changes, stable, unstable. That's your roadmap. So, and please don't try to memorize everything tonight. I need to memorize everything we have learned. Today is the last day I can study. What are you talking? ChatGPT, are you dumb? Don't sit trying to memorize Ruth with stability criteria and say word for word. Instead, try remember the story. All right. All right, ChatGPT. I think I just learned from the things that you said, and it is clear to me now. And so there is only this thing over them, under them, only, right? So is there anything that I will need to learn? So, other than these things in the control system, I will upload you some question PDFs so you can get a, you can make me understand things. And I have done some questions from this paper, but still it's just a little bit hard for me. And um, the things you explain is very clear to me, and but still that the formula that the present say there is a like a percentage sign and e to the power minus zeta phi and something like that. It is a little bit unclear, but like what do you mean by that? um, I will memorize it. So, are there any equations that I need to memorize other than that? Like, I will upload the PDF so you can get an idea. And I want to make sure that whether you extend everything, because I just previously uploaded two images. Uh, Other than these roots, Hermit's stability criteria, I just previously uploaded some of uh, information too. So have you explained all of them also? And if yes, you can go further and explain the things that I have missed. And I want to tell you that I just learned a little bit about Ruth Hurwitz's criteria and things, and I know a little bit of it. So I know the basics. So I need to know that what type of questions will I ever get, and also in this PDF. There are some questions like how to solve memo, things like that. So I don't know them. So can you explain them also in a way that you explain the previous things? Because it was simple, that easy for me to understand. I'm happy.